Hi children, welcome to ICT Learning. So this is the third chapter for grade 10. So if you haven't watched my previous videos for grade 10 chapter 1 and 2, go to the playlist and please watch them. And if you're very new to IT, like if you start the IT from grade 10 onwards, please go and visit my other playlists as well for grade 6, 7, 8, 9 if you have time, because then you have some kind of a foundation and it would be very helpful for your O levels, right? So don't worry. So if you want to start from here, is also you can start, right? This is chapter 3 for grade 10. So it's about data representation methods in the computer system. So this is more like a mathematical subject, right? So for example, now first two chapters, if you study them, it's more into theoretical things and you have to memorize a lot of things and all, and it's more descriptions and all. So it may be you have to study a lot there. But in this case, in this chapter particularly, it's more like maths. So if you get this thing into your head for the first time, and it is only you have to worry about that part, because after that you can do any of these mathematical operations and calculations, and you don't have to memorize anything. So I know there are some students who don't like maths and they feel difficult in maths. So don't worry. If you feel hard in this chapter, please revisit this video again. All right. This will be kind of a revision for you, and do a lot of mathematical things and do a lot of operate like calculations and get these things to your head first, right? Because if so, the whole chapter you don't have to study again or memorize again and again, and this knowledge will be definitely helpful you in your A levels if you do IT, and definitely in your university subjects as well if you do IT related degree. So please get this one. It's a kind of fundamental knowledge you should have if you want to do IT uh, in your exam. Okay. So data representation methods in the computer system. So in here, they are having some discussion, right? They're asking, uh, can we like prepare this application using the computer? They're asking whether you can do it, right? So they are going to type an application like the CV kind of thing. So they were wondering when they're typing letter A, right? They are thinking how this is happening, right? So they are going and asking from their teacher and asking how this letter A, when we type letter A, how it is actually represented in the computer. So teacher is explaining when you type the letter A in your keyboard, what happens is this electronic symbol for letter A go to the system unit, right? Because keyboard is acting as an input device. We learn about input devices. So keyboard is an input devices, and this electronic signal for letter A is going to the memory, right? So it will be represented like this. So if you see, what is this, right? So don't think this is a decimal number, right? This is actually a binary number, right? So the letter A is represented like this inside your computer, right? They are using binary system, right? I will explain what this is. Anyway, it is one and zeros only. So I don't think this is like some kind of a decimal number. This is a binary representation of letter A. So after you type that, the letter A will be displayed on your screen because the monitor is acting as an output device. So based on this, the letter A is represented not as letter A itself, it is transformed or it's converted to a binary number, and then only it is again displaying it as letter A. So we will learn this number system because it's very important, as computers are using numbers to represent all these things, all the letters and words. When we try to give the input, the computer is actually understanding it as binary, and other number systems are used in their backend, right? So what is this? What are these numbers? This group of numbers that the computer can understand is called actually a number system. So in the number system is usually limited to numerals in the number system, and we call them as digits, right? So based on few digits, you can create a number, right? So hope you know about abacus, right? That is the actually first calculating machine of the world, right? So abacus is a simple thing you also used in your even preschools and grade 1, 2, like you may have used this abacus, right? So abacus is a very important thing because we can use similar thing here to understand these number system, because in this chapter, we are going to learn about 4 number systems, right? Binary, octal, decimal, and hexadecimal, right? So definitely you know about decimal number system. That is what we are using in our day-to-day life, like 0 to 9 numbers. You had like, digits you have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So with that, we do a lot of calculations, and whole our education is based on that, right? The mathematical things and all. So that is only the decimal number system, right? But we are going to learn about another 3 number systems in this chapter. So as I told earlier, right, computers actually are using binary number system, right? Actually, they have 2 signal states, right? Actually, 2 kind of voltage levels, right? So one is the high voltage level and the other one is the low voltage level. So for these voltage levels, they have used 0 and 1 digits, right? So that means like on-off status in a electronic circuit, right? So any data in the world can be represented by using these 2 digits of 0 and 1, right? So in the earlier example also, like we learn how these input devices are giving the data into the computer and how it is converted and all. So when data stored in secondary storage, right, this will be sent to the main memory, and then it will be going to the central processing unit, right? You remember main memory is the only memory which can be accessible by CPU, right? So from that actually that data are like kind of converted, and then you are using now here the copying data from the secondary memory to the main memory, right? Here, see the data is always in binary format, right? Then it will be sending to the central processing unit or the CPU, and then the processing happens. Okay, let's start where we use this like numbers in our computer things. So, for example, if you have seen this color picker, right? If you use the MS Paint kind of thing, even you can see this. So here you can actually select any shades of the colors, right? You can use this palette itself and choose, or you can actually change these numerical values here, and you can create any color based on the combination of different like degrees of RGB values. So what is this RGB values? That is red, green, blue, right? So this range will be like from 0 to 155. And from that, you can actually give different values for these RGB values and create different colors. For example, they have given you for this color they have selected. This red is from red's perspective, it's 135. From green perspective, it's 31. And from the blue perspective, it's 120, right? So actually, these colors, like these values, you can represent like this in the binary. That means 135 is represented in this for the uh, actually for the binary system. In down, can you see with the hash there's a value, right? So that is actually the hexadecimal value. We'll talk about this, don't worry. So this is one of the examples where we see like directly how the computer is using numbers in their operations. Okay, so I told you in this chapter, we are going to talk about 4 number systems, right? Decimal, binary, octal, and hexadecimal. So we'll start with decimal number system, right? So before going to the decimal number system itself, in this chapter, you will have these words, right? Unit, number, and the base. right? So unit is actually kind of a digit, right? So it's like a single object, right? Like a mango, a rupee, like that. So this is a unit. So actually, with units which represent the unit, a number is a symbol which represent a unit, right? So with multiple digits, you can create a number. Then there's something called base. In mathematics, sometimes you may have learned base, right? So this is actually from the base, you can find out what's the number system they're using actually in the representations, right? So this base is actually a number of symbols which are used in your number system. Understood? So usually, we represent base in decimal numbers. In any of these number systems, even though it's a binary number system, we represent the base with actually the decimal number. Okay, so from our childhood, we used actually the decimal number system, right? We didn't know sometimes there are so many other number systems because we learn the digits from 0 to 9, right? So all the calculations and everything we have done so far, we used with the decimal number system, right? So normally remember when we use decimal numbers, we don't write the base under that. That's why we have never seen like 150 and down we don't write 10. That is a practice, but you can write. It's not wrong. But as a practice, we don't mention base value for decimal numbers. For but other numbers, definitely we have to mention the base system or base value because otherwise we cannot identify what is this number from, like what is the number system actually, right? So definitely for other number systems, we have to use this base number. I will show you what is this base and all when we are doing other number systems. So when it comes to the decimal number system, right, I told you base is 10. That means we have 10 symbols to be used in this number system. So what are the digits we are using? 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Right? So we have 9 digits to be used in this number system, right? Okay, now think 25. Just you know this, right? But have you ever think like how this 25 is actually created? Maybe you have learned this in grade 1s and 2, but you don't remember actually, maybe, right? So actually this 25 is created 20 plus 5. So how this 20 is created actually? 2 into 10. So and 5 is created 1 to 5. So you will think, yeah, we can think in other matters also, like 20 can be created like 4 into 5 also. So what is this, right? But if you represent it like this, can you see a pattern? Now this one, 1 is like you can represent as 10 to the power 0, right? So any number with any base, but if you have the 0th one, it will be 10 to the power 0. So any number with 10 to the power 0 will be 1. So this is 1 actually into 5, right? And here it's 10 to the power 1. 10 to the power 1 is the 10. So it is multiplied by 2. Do you see any pattern? Getting confused? No. We'll see this thing, right? Counting frame or the abacus. So in the abacus, now hope you remember when you are very small, we learn these are ones, these are tens, these are hundreds, these are thousand, these are 10,000. So if you have 5 here, that means it is 1 into 5. But if you have 5 in here, is it 1 into 5 or 10 into 5? 10 into 5, right? So that is why we are telling this column represent only ones. These columns represent tens, right? We call them as weighting factors of a number system, right? So in the decimal number system, the weighting factors are actually 10 to the power 0, that is 1, 10 to the power 10, sorry, 10 to the power 1, it's 10, 10 to the power 2, hundreds, 10 to the power 3, thousands, 10 to the power 4, 10,000, 10 to the power 6, 10 to the power 7, like that. It goes on. The weighting factors can be anything, right? So this is the way how 25 is created, right? So 5, 20 plus 5, that means 1 into 5. There are 5 balls in this ones column. And 20 is actually created 2 into 10, right? So that means this column always represent tens. So there are 2 balls. That means 2 into the 10 means you get 20. So 25. Understood or not? So if we have another ball here, this is actually representing hundreds. So one ball in this column means 100. So 100 plus 25 is actually 125. So if you want to represent 125, you have to put a one ball here. If you put another ball here, it's thousands column. So 1000 value will be added to the heart. Understood? So hope this is the same thing without the abacus. Now 5 is 5 into 10 to the power 1, 0. 10 to the power 0 is 1. That means 5 into 1 is 5. In here it's 10 to the power 1. That means 10. So 2 into 10 is 20. If you add these two, 25 is created. This is how the decimal number system works. Now we'll go and see this one. A huge number, but has a decimal here if you don't see. So from the decimal, if you go to the left side, the powers are like this, like 10 to the 0th power, 10 to the 1, 10 to the power 2. If you go to this side, that means from the right side of the decimal point, it's minus 1. Minus 1 means actually, do you know, if you have done in the maths, it's 0.1. That means 1 divided by 10. This is 1 divided by 100. Okay, division. It's a the base value is 10, but did you see this power is minus values? Okay, so the weighting factors are like kind of the power is reduced, but in this side it's increasing. So in here, if you think, I will start from here. 3 and this is 10 to the power 2. 10 to the power 2 is 100. So 3 into 100 is 3000, right? So 0 into 10 to the power 1. Actually, we don't have to worry what is 10 to the power 1 because it's 0. 0 into anything is 0, right? But we'll think 10 to the power 1 is 10. 10 into 0 is 0. 2 into 2 into what? 10 to the power 0. Because from this decimal point onwards into the left side, 10 to the power 0, 10 to the power 1, 10 to the power 2. So 2 into 10 to the power 0 means this is 1. 2 into 1 is 2. 2 into 1 is 2. And here it is 7 into 10 to the power minus 1. That means like this, 7 into this. So 7 should be multiplied by 1 over 10. So that is why 7 into 1 divided by 10 is 7 divided by 10. That means 0.7. Understood? And 5 here into this one. 10 to the power minus 2. That means 5 should be divided by 100, not just multiplied by 100. In this side, it's 3 into 100, but this one, 5 divided by 100. So this is the value. You know how to divide by tens and zeros, right? You have to move, there's a decimal point here. You move it one time, it's 0.7. Here you have to move 2 times. Then, now always think there's a hidden decimal point here, right? So you move this 1 time, 2 time, 100, no 2 zeros, you move it like this, or then 0.05. So when you add all this, 300 plus 2 is 302, and this one, if you add 0.75, understood? Think this 7 is having another 0 here, and then add, right? In this one, the addition, if it's hard for you, put it in the correct format, like all the things before the decimal place, add it, and after the decimal place, add it. Okay, hope you know these things, basic things. Okay, that is about the decimal number system, right? This is about binary number system, right? So in the binary number system, we have 0 and 1, right? So on, off, that is the states we represent, right? So in the binary number system, the base is 2. And remember, I told you in all other number systems than the decimal number system, you have to definitely tell what is your base. Otherwise, nobody knows how this number is created. And what are the digits here? 0 and 1. That's it. You cannot write number 2 in a decimal number. Understood? So if you think about this one, right? So this is the number. Don't think this is some 1 million or something like that. Okay, no. This is the binary number, right? So we start from here, right? I told you weighting factors always starts from 0th power, right? So 2 to the power 0 is 1 anyway. But these are 2 to the power 1, 2 to the power 2, 2 to the power 3, 2 to the power 4, 2 to the power 5, 2 to the power 6, like that it is going on. So these are called weighting factors. In the binary, it's 2 to the powers. In decimals, it's 10 to the powers. Got it? Okay. So this is the abacus for the base 2. In here, in the earlier example, we learned these columns represents ones, tens, like that, tens, hundreds, and thousands like. But in binary, these columns represents 2 to the powers. So 2 to the power 0 is 1, 2 to the power 1 is 2, 2 to the power 2 is 4, 2 to the power 3 is 8, like that, 16, 32. That is how this is represented. Understood? So if you have one ball in one's column, means 1 into 1. That is 1. There's nothing here, so you don't have to worry. But this column represented actually number 2. So 2 into 0 is 0. And here this column represents number 4s, like 4. So 1 into 4 is 4. Here it represents 8s. So how if you have one ball, it means 1 to the power, 1 into 8. So 8. Here nothing is there, right? So actually 0 into 16. Here it's 32's column. So here there's only one ball. That means 1 into 32 is 32. So if you have only one ball here, this is not the same as this. This is representing number 32 itself here with the one ball. Here it represented only one. One ball means 1. That's because this is one's column. So binary system is very important and hope you understood. And here we have only 2 digits, right? So the smallest value is called bit, binary digit. So from that we got this word bit, right? Then comes the octal, right? Now we learn decimal system and then we learn binary number system. And here we are going to learn about octal number system. So here there are 7 digits, right? The base is 8 and there are 8 digits, right? So octal number system and the base is 8 and we have the digits 0, 1, 2, 3, 4, 5, 6, 7 like that. So 8 is not included in octal number system. Can you see? So if you think about the similar thing like the earlier examples, this is 236, not 236. That is in decimal. Here it's octal. Can you see the base here? So remember, in other number systems, you have to put this, it's a must to put this base number. In the exam also, if you write any answer without the this base value, it is like a decimal number. So your answer will be wrong and they won't give you marks. So always make sure you write your base in your answers because otherwise it's totally wrong. So in here, the weighting factors are 8 to the powers, right? Can you see? So 8 to the power 0, 8 to the power 1, 8 to the power 2, 8 to the power. These are the weighting factors on the octal number system. And if you represent this in abacus or the counting frame, right? So this is anyway representing ones, yeah. Very similar in all the number system because any power, like with any number with 0th power, it is 1. 8 to the power 0 is 1. So here, how many poles are there? There are 6 poles. That means 6 into 1, 6. That's it. But here it represents 8s. So 3 into 8. Understood? It's 24. And here it is representing 8 to the power 2, that means 8 into 8, right? Don't think 8 to the power 2 is something else. 8 to the power 2 means 8 into 8, 2 times 8. That means 64. And this column represents 512, right? That means 8 to the power 3, right? 8 into 8 into 8, right? So that is these values, if you kind of do a lot of calculations, you will remember. So 8 to the power 3, you don't have to always calculate and say 8 into 8 into 8 like that. You will remember it's 512. If you do, that is the level you should have the expertise, right? Okay, then comes hexadecimal numbers, right? So as the computer is using binary numbers, it's a bit difficult for humans to read and all. So we have this hexadecimal number system because then it's a bit easy for the humans to do the calculations. So here there are 16 digits. It's like you have 16 fingers on your hand, right? So we know from 10 digits, yes, we can use 0 to 9 because there are 10 digits there. So like the decimal number system, these numbers will be there in your hexadecimal also, but we need another 6 more. To represent that for the other 6 digits, we use this A, B, C, D, E, F symbols here. So if you see the chart, right, you have, these are the decimal number system. This is a hexadecimal representation. Up to 9 is the same. 1, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9 is same. But 10 we represent as letter A. 11 we represent as letter B. 12 we represent as C, like that. It's F is 50. So in decimal we write 15. In hexadecimal we just write capital F. Okay. So here base is actually 16, right? And we have 16 digits here, 0 to 9, and then we have A, B, C, D, E, F, right? So F is the largest number of the hexadecimal, right? So this can be, normally hexadecimal numbers we represent with 4 bits, right? So instead of using 4 bits in binary, right, we can use a single number in hexadecimal number system, right? So hope you so in the earlier example, in the color grid, so we have something like this. So normally hexadecimal numbers, we start like this, right? Or we start like with the ampersand and capital H. So if you see these symbols in hash or the this symbol, it is representing actually hexadecimal values, right? So these are the RGB values. That means red is 87, G, for G it's 1 and F. So for B it's 78. That's how it's represented, right? So 87 in hexadecimal is, in decimal is 135, 135. Right? These conversions, don't worry, we'll do it in the later part. So think about this number, 15E16. So base is 16. Right? That means this is a hexadecimal number. So here the weighting factors are going in 16 to the powers. 16 into 0 is 1. Right? 1 into E. E means what? Remember? In this grid, we learn E is actually representing what? 14, number 14. So here, what happens is 16 into 0 means 1, 1 into 50. Understood? 1 into 50. That is what is represented. Here it's 5 into 16. By 16 into power 1 is 16. 16 into 5 is that value you have to get. Understood? So we'll see how it is represented in the abacus or the counting frame. So in this one, this represents ones, very similar, right? So if you have any number of balls, that means into 1. Here it represents 16s. Why? 16 into the power 1, 16. Here 16 into the power 2. So that means 16 into 16 is 256. So there's only one ball, 1 into that value. Understood? So this column represents 16 into 3 times, like not 16 into 3. This is 16 into 16 into 16. Understood? Make it very clear. So this is how the Okay, so in here, in binary, this is represent always with 1 and zeros. And here, octal, you have 0 up to what? 0, 1, 2, 3, 4, 5, 6, 7. And we don't have 8. We have to represent it in octal way. I will tell how to convert this if it's a bit confusing for you. Hexadecimal, 1, 2, 3, 4, 5, 6, 7, 8, 9. And then we have letters up to F, right? But we don't have 17, right? We have to represent at 1, 0. Okay. That is the 16 into 1. Okay. When you do the conversions, you will understand what is this chart actually. So in this slide, I'm going to explain the whole thing in a nutshell, right? So in this video, we learn about 4 number systems: decimal, binary, octal, and hexadecimal. So in decimal, we have 9 digits or 10 digits. Yeah, 10 digits: 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So there are 10 digits. Base is 10. It's 157. So if you want, yes, you can write your base. It's not a problem, but it's not a must. In binary, there are only 2 digits, 0 and 1. 2 digits are there totally, and the base is 2, and you must write your base here. Otherwise, if you don't write, it's like 1000 and 1000 and 100. Nobody knows whether what is this number if you don't write the base. So in the exam, it's a must to write your base. Otherwise, no marks. Don't go to your teacher and ask, teacher, this is correct. Can't you give marks? No, it's wrong. If you don't write the base, it's a different representation. And this is octal. You have 8 digits: 0, 1, 2, 3, 4, 5, 6, 7. 8 digits are there, base is 8, and you can write your number like this with the base 8. If you don't write this base, means it's just 605. But if you write the base, the decimal value for this number is total different number. I will tell you how to do the conversions in the next part, but you have to write this base. Then comes the hexadecimal. We have 16 digits, 0 to 9 you have, and then you have English letters A, B, C, D, E, F. So A is representing actual number 10, and like that 11, 12, 13, 14, 15, and 16 is represented with the English letters. So you have total digits of 16, your base is 16, and this is how it looks like. 1, 4, 5, A, C, and then you have a base 16. So hope you understand the basic about the number systems. We have a lot more to do in this chapter, the conversions and all. So if you haven't subscribed my channel yet, please do subscribe, and please press the bell notification as well, so you will get notifications. And please do comment. If you learn something, if you have any question, please do comment. So all the comments are welcomed. So thank you very much.